This is part 2 of the lecture, adding and subtracting rational expressions. So notice for this level, our denominators are not the same. So we need to find the LCD of 5 and 4. So what number can both 5 and 4 divide into? So we have to multiply the denominator by something so that both denominators are equal to each other. So that's why we need to figure out what number has a factor of both 5 and 4. And the lowest number that has that factor is 20. So what we're going to do is multiply the first denominator. We're going to multiply that 5 times 4. But that also means we need to multiply that entire numerator by 4 as well. And we're going to multiply the second denominator by 5 so that we can get that same 20. But that means we'll also have to multiply the entire numerator by 5. And the reason being that we can do that is because 4 divided by 4 is 1. 5 divided by 5 is also 1. So we're only manipulating the fraction so we have the same denominator. We're not changing the value of the fraction. So we definitely have both a denominator of 20. But now we need to distribute. So we have 4 times 2x plus 1 is 8x plus 4 plus, and then we have this 5 times 3x minus 2. So we distribute again here. We have 15x minus 10. And now we put our like terms together. So 8x plus 15x is 23x. And then we have 4 minus 10, which is negative 6. All of that divided by 20. The only thing you need to do now is decide whether you can reduce this fraction. And if you can't factor anything out of the denominator or the numerator, then you can leave it like it is. All right, moving on to number 2. Here we have a subtraction problem. Be on high alert when you have subtraction, especially when you have more than one item after that minus sign. So we have that minus, and then we have more than one term in the numerator. So that's when you need to make sure that you understand that you need to indicate that you need to distribute here. So some kind of way you need to indicate that for yourself. Now, before I get ahead of myself, we do need to determine the LCD. And we have a 2 and a 6. And so the number that both 2 and 6 can divide into is 6. So that's the lowest number that both 2 can divide into and 6 can divide into at the same time. Now our right denominator already has a 6. So that means we need to change this first fraction. We need to multiply 3 times 2 to get the 6. But that also means I will have to multiply the numerator by 3 as well. So our denominator is 6. But here we have 3a minus 6. And then we need to distribute because this is like a 1 here. So negative 1 times a minus 6. Negative a plus 6 because a negative times a negative is positive. Then we have our like terms here. 3a minus an a is 2a. And notice that our 6's, we have inverses here, so they cancel out. But also notice we can reduce this fraction here. So our final answer is a over 3. And if you wanted to pull out the fraction and put a on the side, this is also the same as 1/3 a. So I just want to show you different ways you can write the answers, because I don't want you to think that your answer is incorrect. If you came up with a over 3, and then, for example, if you saw a solution in the back of the textbook that said 1/3 a, I just want you to recognize it's the same. All right, moving on to number 3. Seems a little bit more complicated. We want to figure out what the LCD is. So what is the LCD for this particular problem? Well, let's look at our 2 and our 15. Definitely out of 2 and 15, 30 would be the number that both 2 and 15 can go into. So definitely 30. All right, LCD 30. Then we have an A and an A squared. Well, A squared, see, I can multiply this side over here by A to get the A squared. So definitely A squared is a part of our LCD. And notice that we have a B here, right? Also, so it has to be a part of the LCD. So 30, A squared, B is the LCD. That's what I want both denominators to be. So I have to multiply both denominators by what it takes to get to the LCD. So, for example, I would have to multiply this side by a 15A, because 15A times 2AB will give me the 30A squared B that I want. And of course, what else I would have to do? I have to multiply the top by 15A as well. And on the right side, I would have to multiply by 2B. So our denominator, we can write this as one fraction now because we are combining fractions. That's basically what our objective is combining 2 fractions into one fraction and simplifying it. So our LCD is 30A squared B. Both our denominators, if you multiply them, are the same. Then we have 15A times 7. What is 15 times 7? Well, I know 5 times 7 is 35. And then carry the 3. So 105A minus 11 times 2B is 22B. Only thing else left to do is to see if you can factor anything from the numerator, and you can't factor the denominator, so this is the final answer. Moving on to number 4. We can't do anything so that 5B looks like B minus 1 or vice versa. So the LCD here is simply multiplying them both together. So the LCD here would just be 5B times B minus 1. That's the only way we can get them to look exactly alike. So on the left side, we'll multiply it by B minus 1. And of course, we need to do the numerator the same. And on the right side, we need to multiply by 5B. So we have the denominator of 5B times B minus 1, numerator of 4 times B minus 1, which means we need to distribute that. So that's a 4B minus 4 plus 5B, which means we have like terms. So we have 9B minus 4 over 5B times B minus 1. And can we simplify this? 9B minus 4 is not factorable. This is not a difference of squares. It's tempting, but it's not. So this is our final answer. So similarly, number 5, our LCD would be x times x minus 6. Again, you have to multiply the denominator times something in order to get the LCD. And this is the only way we can make that happen, is if we just multiply those two denominators together. So for example, on the left side, we'll have to multiply top and bottom by x, and on the right side by x minus 6. So we write it as one fraction, with our denominator being x times x minus 6. Then in the numerator, we have a x times 3x, which is 3x squared, plus we distribute 2 times x minus 6, which gives us 2x minus 12. And what do we have here? Lo and behold, we have a trinomial that could potentially be factorable, right? So you need to attempt that to see, using the AC method, whether this is factorable. You would have to multiply this 3 times a negative 12, and eventually you will see that this is not factorable. So this is the answer, because it's not factorable. Now, if it was factorable and one of the factors was x minus 6, then you would have to cancel out that x minus 6 factor with the x minus 6 in the denominator, for example. So it is important that you try to factor, and if you can't, you can't. But if you can, you do need to attempt it to ensure that you have the most simplified answer. All right, then number 6, this 3 right here is over 1, of course. Is over 1. So our LCD is pretty simple here. It's just x plus 1. There's no need to say times 1, because anything times 1 is itself. So our LCD here is x plus 1. So we're going to multiply this side over here by x plus 1. So x plus 1 is our LCD. We have 2x in the numerator, but be careful here. Again, this is subtraction, which means you're going to always distribute, if you have more than one term, to the right of that minus sign. So be aware that you're going to have to distribute negative 3 times x first, and then negative 3 times 1. So what we have when we put our like terms together, a negative x minus 3 over x plus 1. There's nothing really you could do here, but do you notice that you could factor out a negative 1? So it'll be negative parenthesis x plus 3 over x plus 1. You need to see that both of these are the same. Now, if we were able to get a negative parenthesis x plus 1 out of this, then we would have been able to cancel, and our final answer would have been negative 1, but we didn't. But I want you to see that you need to be aware of such situations. All right, moving on to number 7. In this case, there's no way we can get 3x minus 5 to look like 2x plus 7, or vice versa. So we put them both together to formulate our LCD, which is 3x minus 5 times 2x plus 7. So what we're going to do is multiply the left fraction by the 2x plus 7. And it doesn't matter where you put it, but I'm going to prefer the numerator. I'm going to put it in to the right of 7, because I know I have to distribute. And over here, we need to multiply by 3x minus 5, and of course the numerator as well. So rewrite as one fraction 2x plus 7 times 3x minus 5, or vice versa, 3x minus 5 times 2x plus 7. Now in the numerator, we're going to have to distribute over here. So that's 14x plus 49. Okay, beware that minus 15x plus 25. Okay, please learn your integer rules. There's a negative times a negative, so that's why it is positive. All right, moving on. We have like terms. 14x minus 15x is negative x, and then we have a 49 plus 25. What is that? I see that it's going to be a plus. 14, carry the 1, 74 over 2x plus 7 over 3x minus 5. Here I know that nothing's going to turn out to be 2x plus 7 in the numerator. But again, you could factor out a negative 1, and then it'll be negative parenthesis x minus 74 over 2x plus 7. 7 times 3x minus 5. It's just good to know how to manipulate negative ones and extracting that from a polynomial, because it may be helpful in other situations. Number 8, we have 3x minus 1 over 6y squared minus x plus 5 over 9xy. Here, yes, we do have to be considerate again of this minus sign here, but LCD, let's look at the 6 and the 9. What is the lowest number that both 6 and 9 divide into? I would say 18, right? 6 can go into 18. 9 also can go into 18. Now, I see that we have an x here as well, so I definitely got to put an x in the LCD. And if we compare our y's with each other, we could just simply multiply a y to this one to get this y squared. So we want both our denominators to have a y squared in it. This is how we can get both of them to look alike. So we're going to multiply the left side by what to get 18x y squared? Well, it looks like we're going to have to multiply it times a 3 and an x. So let's multiply top and bottom by 3x. That would give us, let's put a little dot here. That would give us the 18xy squared that we are looking for. And on the right side, we need to multiply by a 2, because 9 times 2 is 18. We already have the x, so we don't need to worry about that. But we do need another y here. So I'm going to put it in the front here because we can distribute that. So our denominator is 18xy squared. And this problem is a little weird, but we can handle it. We can distribute here. That'll be 9x squared minus 3x minus, this part over here is especially weird because we have a y in the numerator here. So that's 2xy minus 10y. Okay. And then there are no like terms, as you can see. We can't factor anything out of that numerator. So we're going to leave the answer like this. All right, we have moved on to the next level. So congratulations, you have leveled up to level 3. Now in this level, the first step is to factor the denominators first before determining the LCD. So for example, number 1, we have x plus 4. Of course, we can't do anything to that, but so I'm going to rewrite that one, 3 over x plus 4. But we can factor this trinomial here. So what are the factors of x squared plus 8x plus 16? Well, the factors are x plus 4 times another x plus 4. Now, are the denominators exactly the same? Actually, no, because the first denominator has 1x plus 4 and the second denominator has 2, right? So they're not on the same page right now. In order to get them to be the same, we will have to multiply the first denominator by another x plus 4 so that both denominators will have x plus 4 times an x plus 4 or x plus 4 squared. But there's no need to write it as x plus 4 squared because you want to simplify it in the end. And you really need all the factors kind of laid out so that you can determine if you can cancel common factors. So rewrite x plus 4 times x plus 4 in the denominator. Then we're going to distribute to the left here. So that's 3x plus 12 plus a 2x. And when we add like terms here, we're going to get a 5x plus 12 over x plus 4 times another x plus 4. Now you can see here that 5x plus 12 is not factorable, so it is simplified. Now at this point, when you realize you can't simplify it any further, you could rewrite it if you wanted to as 5x plus 12 over x plus 4 squared if you wanted to. But notice I put or. I will take that answer or this answer. Moving on to number 2, we have this denominator, which is factorable. So what you need to do is factor it. So the factors of a squared minus 4 are a plus 2 times a minus 2. And so what is the LCD? Well, in order to get them both to be the same, we want in both denominators a plus 2 times a minus 2. So that would mean that I would need to multiply the denominator on the right by a minus 2. So we will have a denominator of a plus 2 times a minus 2. Then in the numerator we have a minus 3a. Can you tell me what else I need to write in the numerator? If you said plus 6, then you are right, because a negative 3 times a negative 2 is positive 6. Then a minus 3a are like terms, so we have negative 2a plus 6 over a plus 2 times a minus 2. So here's a situation where you could factor out a negative 2 from the numerator. So you'll get negative 2 times a minus 3 divided by a plus 2 times a minus 2. So number 3, we have the denominator x squared minus 4x. That's factorable, so we rewrite it as 8 over, take the GCF out, so that's x times x minus 4 plus 2 over x. So what is the LCD? Well, we can get both our denominators to look like this, x times x minus 4. So what we can do is multiply the second denominator by x minus 4 and the numerator as well. So when we rewrite this fraction as 1, we have 8 plus, we're going to distribute on the right, 2x minus 8 over x times x minus 4. And what do you notice? The 8's cancel out, and you have 2x over x times x minus 4. Can we simplify even further? Yes, because the x's cancel out, and you have 2 over x minus 4. Moving on to number 4, we have 3 fractions that we are combining as 1. So we rewrite each one of these fractions, making sure that we factor the denominators that are factorable. And x squared minus 1 is factorable. So that's x plus 1 times x minus 1 minus 3 over x minus 1. So what is the LCD? We can get all of our denominators to look like this, x plus 1 times x minus 1. So we need to multiply the first denominator by an x minus 1 so that it can match up, and the last denominator by x plus 1 so that it could match up. Now, our denominator is x plus 1 times x minus 1. We need to distribute this 3 and multiply it times x minus 1. So we will get 3x minus 3. Then we're going to write x plus 5. We didn't have to multiply the middle fraction by anything, so we just rewrite it. Also, be careful about this minus sign. Everything to the right, we need to distribute that -1 there. So we have negative 3x minus 3. Then we're going to put our like terms together. We have a 3x, we have a negative 3x, so that's going to cancel, but we still have this x in the middle. So we have x, then we have a negative 3 plus 5, which is 2, minus 3, which is -1. So we have x minus 1 over x plus 1 times x minus 1. And we're not done yet because x minus 1 cancels with x minus 1. And what is our final answer? If you said 1 over x plus 1, you are correct. So next, we have 2x minus 1 divided by, so what are the factors of x squared minus 25? They are x plus 5 times x minus 5 plus, then we have 2 over 5 minus x, but let's rewrite that in descending order. If so, it would be negative x plus 5. Now, x plus 5 and negative x plus 5 are not the same. So what we're going to do is manipulate this so that it is the same. So what we could do is factor out the -1. So let's rewrite the first fraction, 2x minus 1 over x plus 5 times x minus 5. But let's factor out a -1 from, or the negative from the denominator. So that would be x minus 5. So we're getting really close here because we have x minus 5 here. We have x minus 5 here. All we really need to do is move up our negative, right? So it's conventional that you move your negative signs up anyway. So when we rewrite this, 2x minus 1 over x plus 5 times x minus 5, what we have here is a plus times a negative, right? So this positive times a negative. So the negative would dominate here. So we will put minus 2 over x minus 5. So this is the same as this. Now, our LCD is x plus 5 times x minus 5. That means that we need to multiply the second denominator by the x plus 5, so our denominators are the same. And likewise, we do have to multiply the top by the same thing. So what we have, same denominator, let's combine our fractions. We have a 2x minus 1 minus 2x minus 10. And again, why do we have that? Because we had to distribute that -2, multiply it times x plus 5. Now, what happens here? Well, the 2x minus 2x cancels out, and we have a -11 over x plus 5 times x minus 5. So for number 6, we need to factor the denominators first, of course. So we have a plus 2, and then we have these trinomials, but our leading coefficient is 1, so should not be much of a problem, too much of a problem. So we have a times a will give you that a squared, but we need factors of -2 that add to 1. So we're going to put negative 1 times positive 2 will give us that negative 2, but we'll add to a positive 1. And then on the right side over here, we have a times a again, but this time will be 3 and 1. It'd be plus positive 3 and negative 1. So our LCD, notice, is a minus 1, a plus 2, a plus 3. So 3 distinct factors. So on the left side, we have the a minus 1. We have the a plus 2. We're missing the a plus 3. So we need to multiply top and bottom by a plus 3. On the right side, we have the a minus 1. We have the a plus 3. We're missing the a plus 2. So that's what we're going to multiply top and bottom by a plus 2. So now that our denominators are the same, we're going to rewrite this problem. I'm going to erase this over to the right here. So we're going to rewrite it as a minus 1 times a plus 2 times a plus 3. Again, the order of these factors does not matter. But this is kind of unique. We have a binomial times a binomial here, which means we need to FOIL that out. So a times a, first of all, a times a is a squared. A times 3 is 3a. 2 times a is 2a. And then 2 times 3 is 6. We're not done. We have a 3 times a plus 2. So we have to distribute that. So that's 3a plus 6 again. So we now need to combine like terms. So that's a squared. We have 3a plus 2a, which is 5a, plus 3a, which is 8a. And then we have this 6 plus 6, which is 12. Divided by a minus 1 times a plus 2 times a plus 3. Is this trinomial factorable? Is the question. Is that trinomial factorable? Factors of 12 that add to 8 are 6 and 2, right? A plus 6 times a plus 2 over a minus 1. See how important that was to factor that, because now you see that we have a plus 2 and a plus 2, which cancels out, right? And then our final answer is a plus 6 over a minus 1 times a plus 3. Number 7, we have 4 over 2x squared plus 5x minus 3 plus 2 over x plus 3. Now, we need to factor using the AC method. So what I want you to do, pause the video and factor that trinomial using the AC method. So I'm going to guess at the factors. I'm going to put x plus 3 in 1. I'm going to put 2x. And then we need it to be a negative here. So it must be this. If I FOIL it out, I can check it. 2x times x, 2x squared plus 6x minus 1x minus 3. So that works out. Now, so our LCD would be 2x minus 1 times x plus 3. So we need to multiply top and bottom by 2x minus 1. So we have equal, let's combine the numerators, 4 plus, we distribute here, so that's 4x minus 2 over 2x minus 1 times x plus 3. These are like terms, so what we have is 4x plus 2 over 2x minus 1 times x plus 3 is there anything else we can do to this problem? We'll take out a 2, right? And then that'll be 2x plus 1. Very, very close. It was 2x plus 1. So that's very close because it could have been 2x minus 1, and that would have canceled out the 2x minus 1 at the bottom, but it doesn't. So both of these answers are correct. Last, we have number 8. We're going to factor the denominators first. So 2n over n plus 5 times n minus 5. And then what about the second denominator, 4n plus 20? Is that factorable? Yes, because you can take a 4 out. That's your greatest common factor. And you will have the other factor of n plus 5. So what is the LCD? The LCD is 4, because that's a factor in the denominator, n plus 5 times n minus 5. So if this is the LCD for this particular problem, what are we missing from the first denominator? We are definitely missing a 4 here, so we're going to multiply 4 top and bottom on the left side, and on the right side we're missing that n minus 5. All right, so we're gonna combine our denominators. Well, combine our numerators. First, multiply. First, we need to write our LCD because both denominators are the same. And then we multiply. 4 times 2n is 8n, minus, we have 3n plus 15. Why is it plus? Again, negative times negative is positive. And then we have like terms here, 8n minus 3n. That's 5n plus 15 over 4 times n plus 5, n minus 5. Now you could rewrite this as 5 times n plus 3, but notice it doesn't cancel out with anything in the denominator. So either or answer is correct for this problem. This concludes the part 2 of the adding and subtracting rational expressions.